Okay, we are here with the future. We are going to make a bioplastic in a Cantonian high school lab. So we're going to start off, let's have a quick look at the ingredients if you ever wanted to make this at home. Okay, we've got some distilled water. Distilled water just means there's no salt. I've got some glycerol. For those of you which are thinking, I've learned about glycerol, Miss Hilston. It's exactly the same type of glycerol which is in our fats. I've got some starch. I've got some sodium hydroxide, I've got some acid, and I've got some pH paper. We're going to get on with making this biopolymer. Now I'm just going to own up to it. It's quite a complex recipe, so I've got my recipe on the side. If you think, oh, Sir's cheating, I'm owning up now, so it doesn't count. So first thing I'm going to do, I'm going to use my measuring cylinder to measure 22 centimetres cubed of my lovely distilled water. Quickly do that now. There's 22. Well, and I'm going to pour that into my beaker, which I've got on the balance. I then need to take, have a little check, 3 centimetres cubed of my hydrochloric acid. So I've got that here. Probably not the best measuring cylinder in the world. I'd probably want a smaller one because it's going to be quite difficult for me to see 3 centimetres there. But impressed with that, miss? Bang on straight away.
I'm very impressed.
I'm then going to, oh, should I put on the wrong thing? I'm going to then quickly, what we call tear the balance. At the moment my balance has got a reading. I'm going to set it to 0 and using a very complex tool known as a spoon, I'm going to put 4 grams of
potato starch in. Okay? Be careful, I don't have it too much. 4 grams, a lot more than I thought, miss, I have to say.
Now this starch is what's going to thicken this, okay? Often like cooking, you put potato in something to thicken it. This is what's thickening it, the starch. And finally, my glycerol. And I'm going to take 3 centimetres cubed, is it? 2 centimetres, very little amount. Now, bit of a dangerous chemical, okay? So I'm going to be very careful. I'm going to keep my hands away. I only want the tiniest bit.
So there's quite a few hazards, so is there?
Quite a few hazards, to be honest, miss. It's not the, got to be safe here. I wouldn't try this at home.
No.
No.
It's not a Saturday night job then?
No, not a Saturday night job. Certainly not this. And then, get my glycerol, tap it out of my measuring cylinder. And then, I can give a little stir. Get everything mixed in together. So I'll show you, I'm going to have a milky, am I in the right place, miss?
Yep.
I'm going to have like a sort of white milky colour going on. Try and get all that powder in as much as possible. And then, to make this sort of gloopy and thick, I'm going to use what we call a watch glass. We've seen this before when sometimes making crystals. The idea behind this is I'm going to heat this very gently, but I don't want any of my product to escape. I don't want steam going everywhere. So I'm going to use a watch glass. The one we've got today is quite a little bit bigger, just because the beaker is bigger. So I'm going to place that on my gauze. Bit of a hazard now, hot apparatus can burn. If I really wanted to control that, at this point, I'd wear gloves, but I'm okay. So this is going to pop to the time lapse. We're looking at 15 minutes gentle heat. See you in a bit. Okay, we just left that on for 15 minutes. So I'm going to stop my stopwatch. I can put that to the side. We're now going to remove the heat. I can turn the flame off now. That's the last time we're going to need that Bunsen burner for this practical. Now if you remember all the way back to the start, we put some acid in. Now, if you remember from our chemistry on acids and bases, if we were going to use a pH indicator now, we'd go down to sort of red and yellow colours. But for a really top quality plastic, I need a neutral solution. So to neutralise my acid, I'm going to use some sodium hydroxide. And I'm looking to turn my indicator paper from yellow to a greeny colour. Okay, I think this is going to be quite tough. Got there finally, getting that colour to green. Quite difficult. I used about 3 centimetres cubed in the end, but I added drop by drop just in case. Next thing I'm going to do, I'm going to add a few drops of red food colouring. This is just to make my plastic red. If you wanted a green one, you'd use green, yellow, yellow, blue, blue. I'm going to add that in. I'm going to stir thoroughly then. Okay. Now at this point, I'm just making sure that my red colour is spread all the way through my plastic. Okay, it's quite gloopy at this point. So I'm going to make sure that I've got that red colour lovely in there. It's going to come out a reddy-orange colour towards the end. Once I'm happy with that, I've got to go back and check my method again. I'm going to pour it onto a Petri dish. Okay, you've seen this with the agar prac that Miss Hilson and Miss Lahan did. So I'm just going to simply, not very scientifically, pour it onto my agar plate. Trying to get as much of that lovely red plastic as possible in. And then I'm going to spread it round as thinly as possible. Obviously, the thicker it is, the longer it will take to dry. And we'll come back with some results for you in a second.
Right, so the biopolymers has been left for a couple of days, and then the video that is playing currently is the one just with the glycerine added to it. Okay, this type of biopolymer, okay, I know the video is all a little bit over the place as I try to show you with one hand, will be quite flexible, okay, quite tensile strength. Okay, so it's really hard to break. I know it's slightly cracked, but that's just how it went in the Petri dish. It's quite bendy, and improved water sensitivity. It means that water would run off it. Okay, if we had, however, been able to form a sample without glycerine, it would be really brittle, really easy to break, and it would absorb water quite easily. So there's the two different types of biopolymers. Biopolymers, like we previously discussed in the video, are used or hoping to be used instead of plastics. They're sometimes called bioplastics, and this is just an example of it. Okay, they're really flexible, increased tensile strength, as long as you use the correct equipment and ingredients.